Welcome. Today we're going to modify our approach. We take a new document, Accenture's TechVision 2021. And I have not read the document actually, but I let my artificial intelligence system read the document, analyze the output of my AI, and I'm trying to guess, or maybe I can extrapolate, the content of the document. So let's have a look how this plays out. We start with BERT base edition, and as an input we take all the sentences. We do not clean anything at all, no padding, no nothing. I want to see if we go here with the pure sentences, what is the performance of our preliminary AI system. We're going to use again BERT. We apply the pre-trained model from John Snow Labs. The document, as already mentioned, Technology Vision 2021 by Accenture. And here we go. The code is identical to edition 1 and edition 2. We run through our libraries, we import them. We have our stop words, our sentence tokenizer, our word tokenizer, and the sentences are here in all PDF. Since it's a PDF document, I converted it to a text document, a string. I replace the comma, the semicolon, and the etc. And here we go. We split the huge string into single sentences based on full stops. And then we transform it, of course, to a Panda data frame. And this is our data frame. We have a column with text where each row of our Panda data frame is a sentence. Altogether, we have about 1,212 sentences. For the sentence embedding, we use the BERT model. And given that we have a huge amount of already pre-trained model, today we are gonna go with BERT base model again. And if you have any questions about what is BERT, if you're unfamiliar with BERT, there's a short introduction what is BERT and the methodology, how BERT sequence a sentence or a content or a document. I found a nice paper here from Google submitted at the end of 2020, where they explain a little bit the word piece tokenization methodology. And keep in mind, BERT uses about 30,000 word pieces. So here we go. We load our sentence embedding based on BERT base. For heaven's sake, come on. We have a look at the sentences after some manipulation. Here we have the head, here we have the tail of the sentence, and you can see at the end there's quite a long sentence, but no problem at all. We should stay well within our 256. Now we apply BERT base on our data frame with the column text where all our sentences are. And after 58 seconds, we come up with the result of the computation. We have now a data frame where for each and every sentence, we have an embedding of the sentence. You are familiar with our code from episode 1 and 2. Just gonna make it a little bit prettier. Our data frame, our sentences, and the embedding. We already know that the embedding is in 768 dimensional point data set, coordinate set. And when we merge it with the sentences, that we have everything together, the sentence and all of the different coordinates, this is where we end up, and we can save it for later use. Again, we pick a sentence from within the body of sentences. I choose, for example, sentence number 15, and we can calculate the cosine similarity to all the other sentences based on our representation of each and every sentence in a 700 and 58-dimensional topological space. So as you can see, sentence number 15, when the normal ways of operating were removed from their equations, organizations proved they could wield technology to try new things, change with unprecedented speed and innovation. And the answer of the system is the closest sentence with the allegedly most closest meaning. As more organizations digitize their physical operations and system with intelligent twins, they will be able to share design information and insights easily across silos. Interesting choice. Okay. Also, you can just put in your own sentence, which is not part of the body of documents that we already analyzed. So we have here, instead of trust, we say leaders. Yes, leaders, machine learning, university. And we put in change. We embed this sentence with our pre-trained model. 1, 2, 3. Come on. Just one sentence. What can be so difficult? Yeah, I have no graphic card from NVIDIA, so no CUDA cores, no nothing at all, no GPU acceleration. All the work is done on a CPU from AMD. 6 cores, 12 threads. And if we have now our embedding of our new sentence, we can easily calculate for our given sentence, leaders, machine learning, university, change. System comes up with the closest sentence, our digitally led partnerships driving value for your enterprise. Wow. Yeah, we can see, since we have not cleaned our input sentences, we have question marks, we have numbers in front of sentences, we have here a segmentation mark, we have here percentage signs whatsoever. But this is just to give you an idea, if you do not clean your input sentence, what you come up with. How intelligent, question mark, is the system? Leadership demands technology leadership. Okay, yeah. Leadership demands technology leadership. We have it here another time, since BERT is content sensitive within a sentence. So maybe this is a direct reference to this. Create an engine for continuous innovation, ecosystem scale thinking, lead, digital twin strategies. Okay. So you get a first idea. If you have your own topic, you can formulate your sentence on the topic you're interested, and you can have a very rough idea what the content of the document is similar to. Again, we reduce the dimensionality of our functor. We reduce it here in a 5-dimensional topological space. We end up with the embeddings in 5D. Yep. Come on, a little bit faster, please. So for each and every sentence, we have X, Y, Z, Z1, Z2 coordinate of the system, and we can cluster now. We come up with cluster 0 to 5, so we have 6 cluster. The system decided that given the embedding and the pre-trained model, it can identify 6 thematic clusters, and cluster number -1 is regarded as noise. All the sentences that the system does not assign to one of our clusters 0 to 5, it puts in the bin -1. To get an idea of the amount of sentences, we have in total 1,261 sentences, and in cluster -1, noise, we have 561 sentences, which is quite a lot of if you compare it to 1,261. But okay, let's have a look at the cluster. What is the cluster? What are the sentences of the cluster? And to get an easier visualization, we do UMAP again. It's 3-dimension. We map it so that we end up with a data frame where we have for each and every sentence, we have a label that indicates this belongs to cluster number 1, cluster number 2, cluster number 5, and we have now reduced it to a 3-dimensional topological space X, Y, and Z. And from now on, it's easy to start a visualization. I use network X and Plotly, And wow, wow. Here we have a little bit unusual three-dimensional representation of all our sentences that are not noise. Those are all the sentences that the system analyzed, clustered, and encoded, which has an interesting figure. So let's look at it. Clearly, we have some linear structure within the space and some rather nicely clustered from top. So let's try to deduct what is the content of the document. Let's have a look at the first cluster. Let's take this one here. In the U. Wow. Yeah. Word piece. BERT uses word pieces. If there is a word that is not within the vocabulary of the pre-trained model from BERT in the 30,000 word pieces, then it segments the word smaller and smaller and smaller until it arrives, oh wow, S, at single characters. Like you see here, we have NS. BERT had no idea, the word we had in our input sentence was not in the BERT vocabulary, so he decomposed the word and we ended up with single characters. Okay, S, anywhere, everywhere. Okay, the challenge, culture, security, business, go factory, scenarios. I technologist, no more, the I in experience. Consider supply chain, workforces are becoming human plus. Just look at the restaurant industry. It was designed in 1959. Wow. Okay. So if you have not read the document, it's a rather bizarre clustering that we find here. But okay. It's visibly an outlier, so okay. I could not deduct any meaning right now. Ah no, yes, you can see here the sentences with the number in front of. Okay, reinvent, completing the picture. Biotechnology vision. Ah, this could be the pages. Okay. Leadership demands technology. Leadership demands technology leadership. Okay. Your strategic leadership has to be very, very familiar with technology leadership, whatever this means. Okay. Revenue growth. Visionary technology goals are at the core of my organization's overall strategy, including larger societal goals. Well, really? Growing the enterprise reach and responsibility, focus on building technical wealth, emphasize the culture, bridging the gap, think beyond the walls of the enterprise, get to know me, broaden the horizons of leadership. Okay, definitely a kind of leadership and technology leadership cluster. Here we go. Natural language processing, low-code platforms, and robotic process automation. Yeah, makes sense. Smart sensor, robotic process automation. Makes sense. Extended reality. PPE. Okay. How are you training your workforce to think like technologists? Train your workforce to think like technologists? Okay. So here we have the leadership cluster, and now we have more or less that we have to train the workforce for the technology challenges ahead. How are your digitally led partnerships driving value for your enterprise? Okay, makes sense. How can I update this product to be more sustainable? Okay. Is your enterprise poised to take advantage of technology's growing democratization? Okay. Suppose this has to do with open sourcing. If customer be reshaped by next generation technology. Okay, I see here. Okay. Which business relationship will be transformed by the growth of a multi-party system? Ah, that's interesting. But make no mistakes, transforming the enterprise into a technology leader cannot be obtained to the oversight of the CEO or the CTO alone. Okay, so you have to motivate your whole crew, your whole team. This is the team cluster. This is the leadership cluster. And now it gets interesting. What is this here? What's about the red cluster? Overcome the beta burden. Okay. Enterprises aren't all starting entirely from scratch. Just enough is not enough now. Okay, we are left with a global set of circumstances we have never seen before. Yeah, okay, COVID. A new future is on the horizon, and that's different from what the world expected. Yes, okay. It's a signal of things to come. Okay, let there be change. The future of work starts today. So this, I mean, having not read the document and just looking at what our preliminary artificial intelligence tells us, this is about the future and how to start changing today for a better future. Let's put it in these words. To ensure you have a place in this future, you need to begin your transformation today. Okay, this is the be prepared for the future, change is coming cluster, okay? Well, right next to it is the blue cluster. Let's have a look at the blue cluster. What is the blue cluster? Bolder actions will fall flat without the technology foundation needed to support the ambition. Okay, technology savvy. Few companies have realized it yet, but this new future gives you a chance to really rethink your operational models. Okay, cloud-based, put everything in the cloud, your supplier, all the supply chain whatsoever have already taken a step toward flipping their approach. Okay, still waiting for the new normal to emerge before them. Others are already building them. Okay, be active, be strong. This will be a large, slow to emerge cultural shift. Cultural shift, definitely. Foremost, this comes with added responsibility, oh yeah, for the leadership. Digital performance gap that widened seemingly overnight. Oh yeah, for sure, yeah. Oh yeah, where's the rotation? Yeah. This comes with added responsibility. Massive shift to cloud underway. Okay, yes. Oops. Now the initial rush to get out of the office is over. It's time for the other half of the equation. Okay, we don't know the equation yet. And don't forget the technologies that are allowing employees to work remotely in the first place because attackers haven't. Okay, something about cybersecurity, I suppose. This will be a large, slow to emerge cultural shift. Yes, okay. Green. Heaven's sake. What? As you can see, the mightiness of a sentence sometimes is really intimidating, but here we go. Businesses are finding immense financial opportunity in constructing new ecosystem-based business models. Yeah, okay, so construct new eco-based system models. Okay. Driving the reinvention of basic components of society's fabric. Wow, that's a complicated task. As more enterprises build and connect intelligent twins, bringing more of the organization into digital space, they are opening something of new opportunities and ways of doing business. Okay, everything is transformed to the cloud. You will have your intelligent twin software encoded somewhere in the cloud. Okay. Excitement over Bitcoin. Well, widespread digital transformation are the building blocks to create almost anything. Okay, you can see this is here about digital twin, anything on the cloud, simulation, software simulation of whole ecosystems, the variation of ecosystem, the evolvement of ecosystems within the fabric of society. Interesting, very interesting cluster. And now to the main cluster, here we go. Fetch Robotics, an industrial robotics provider, saw percent increase in demand. Okay. Takeda, pharmaceutical company in Japan, is fast-tracking its digital transformation. Yes. Okay. Wow. Amazon sellers conduct algorithmic advertising. Found it took just 1 week to enter. Okay. Adidas. Okay, so we have examples of leaders in their industrial segments. This is a description and explanation what they have done, I suppose. Verifiable test results. Integrates digitalization for an enhanced customer experience, including using AI as part of its decision-making process. Wow, if you include AI as part of your decision-making process, I'm looking at a document generated by my preliminary AI, and I can tell you to base decision on this, what I try to deduct and what I associate freely from those sentences. Wow, this is really, this is an adventure. People can pick and choose for themselves what to automate, allowing them to focus on the things they do and like doing best. System smart sensors were able to stream data and generate insights about body temperature, movement, social distancing, and mask detection. Okay. Sensors, intelligent sensors, digital twins in the cloud. The interactions or the responsibility of the leader to understand the digital system, the social fabric, all the preconditions for the ecosystems to generate new ecosystems, to generate new wealth within this new configuration. Wow, seems a very interesting article or a very interesting document to read. Imagine the difference if more enterprises had faced COVID-19 with intelligent twins for every asset. For every asset. Holy smoke, can you imagine the amount of simulation and the cross-reference between each and every parameter of each and every subsystem for every asset in the system? You completely model real-world interactions in complex systems, in chaotic systems, and you build in the cloud software-based intelligent twins for each and every asset. Wow, that's quite a challenge. Ah, interesting. Okay, but for our exercise today, you see, I think I got a glimpse of what the content of the document could be with just downloading a pre-trained model based on BERT, applying no cleaning at all to our sentences, leaving in all the question mark and whatsoever. And I think it's fascinating to get an idea what is the content. And as in episode 1 and episode 2, now we're gonna have a look at the top words, the bigrams and the trigrams of all the most important top words, bigrams, of all the sentences within a cluster. And we simply ask, applying the nice code by Martin Groth and Rost, what are, another one, and here we go. What are top 10 words from the sentences within each cluster? So, here we go. The biggest cluster with 279 sentences, cluster number 3, has intelligent twins, digital twins, real-time simulation, I suppose. Nice, we got this. Intelligent twins, digital twins in the cloud. You simulate completely for each and every asset, all their complex interactions. Wow. Cluster number 1 with 103 sentences. Organization overall, that's a little bit, that's not enough information for me. Next cluster, business technology, democratize technology. Okay. Company need garbage. I don't think this is really what we're looking for. So let's have a look at all the top words. Intelligent twins, that's real clear. Real-time data, supply chain, mirrored world, intelligent digital twins. Very interesting trend. Sounds fascinating. Organization overall has to change. Overall strategy for a better future. Architecting a better future. Okay. It's about change. Business technology. Digital transformation, digital age, accelerate digital. new opportunities, technology solutions. Okay. Now, this is an interesting cluster. I'm not sure what to make out of it. Companies need, garbage, garbage. Place, future, need, accept. Employee, environment. Companies need, accept. Work starts today. Okay, work starts today to change the future. Ensure, place, future. Well, I would think we need to deep dive into cluster number 2 to understand really the meaning. Cluster number 5 with 81 sentences. Vision of the future, new kind of leadership, future one, kind leadership, new kind, leaders, future. Okay, yeah, all about the leadership and the future. Our leader, our strategic leaders who fully understand the technological implications of each and every actions they undertake. Wow, congratulations. And the mirrored worlds, the technologies strategically mirrored worlds, technologies, strategically mirrored world. Wow, the trend is really to completely mirror the real world in a huge simulation to be able to calculate if there are fluctuations within the system or some of the parameter conditions you change, what are gonna be the results in the real world. Interesting, absolutely interesting. Okay, so as a first exercise, with a very simple AI system, no cleaning at all, just running through it, I think we get some interesting insights into the document. If you're interested, read the document for yourself, be surprised. And in the next episode, episode 4, I will prepare for you that I cleaned all the input sentences, that I apply BERT large with 1.24 gigabyte pre-training models, and we're going to have a look at the same analysis again, and let's see if we come up with a better explanation, if the clusters are more clearly defined, and what will change if we apply a better BERT large system to our little artificial intelligence. Thank you.